you are hearing this talk. It's my great pleasure to introduce today Joaquin Quiñonero Candela. He's a former distinguished technical lead for responsible AI at Facebook. I'm going to be very short because Joaquin wants to give a longish talk, so I will just introduce him very briefly. He lived in Morocco from he was 3 until he was 18. He studied there in French and Spanish, and he learned to appreciate Arabic, and he can still read a little bit of about Arabic. Then he studied telecom engineering in the University Carlos III in Madrid, where we briefly coincide when he was in his last year, and I was starting there as an assistant professor. And then he went to the DTU in Copenhagen to do his PhD that he jointly with the MPI in Tübingen, and that's where he get his appreciation for Bayesian modeling. And after that, he became a postdoc between the Fraunhofer Institute in Berlin, working with Klaus Robert Müller, and still in the MPI working with Carl Rasmussen. So Joaquin, welcome. Thank you for accepting our invitation to give a talk at ECML, and please talk to us about AI fairness in practice.
All right, thank you so much, Fernando, and thank you, everyone. I understand that this is the last talk of the day, so you've had a very long day already. So hopefully I'll be able to make it entertaining. All right. As Fernando said, I'm probably going to try to cover too much material, and a lot of what I'm going to cover reflects a bunch of the perspectives and experiences that I have gained through almost 15 years in industry. I first joined industry when I joined Microsoft Research in Cambridge in the UK, and that was back in 2007, and I worked on probabilistic machine learning. Then after that, I joined another team, a product team within Microsoft, the Bing search engine when it launched, and I built the team that worked on click prediction and then on online auctions. And then a little over 9 years ago, I joined Facebook, and we relocated with my family from the UK to Silicon Valley, where I live right now and where I've been living. And exactly 1 week ago, I resigned from Facebook to take a bunch of time off and spend time with my kids who are growing and leaving to college now, and with my wife who's rebooting her career. But the things I worked on at Facebook fall into two big categories. I first built a team called Applied Machine Learning, or AML, and I'm actually wearing the t-shirt from that team that built the entire AI and ML stack used by every single product team across the company to put ML into every Facebook product. And then after that, about 3 years ago, I switched to work on responsible AI. And in particular, the area where I went a bit deeper is the area of this talk. I went deeper into fairness in AI and algorithmic bias. So before we talk about that, I want to zoom out a little bit and give you a typical impression of what the scale of an AI deployment is in a big tech company and in one of the services that you use every day, right? So typically, you're looking at in the order of 1 billion users or customers every single day. And each of these customers is going to have in the order of 1,000 new pieces of content or potential products that they are, that they might be interested in. And especially if the customers are like my own children, they're going to be using these services tens or hundreds of times per day. So if you multiply all these numbers together, you get to the result that you're making between tens and hundreds of trillions of AI or ML inferences every single day. And so what are examples of such services? Well, you can think about any social media application where you get a ranked feed of content. You can think about online marketplaces like Amazon, obviously. You can think about things that we don't talk about enough, which is using AI to protect people against harmful content and harmful actors. And I'll talk a little bit about that later, but this is the scale of things. Now, of course, the reason we're here today to have this talk about fairness in AI is that while big AI offers amazing opportunities and value for people and for society, it also poses some pretty difficult ethical challenges where we need to counterbalance the benefits with the risks, right? So if you think about AI to keep people safe and identify terrorists or identify criminals, right? You got to counterbalance that with the risk that governments will use that same AI for mass surveillance, right? If you think about using AI to help connect people to content they might not have discovered otherwise, you got to balance that against the spread of misinformation and manipulation, etc. Right? So today, what I'm going to do is I'm going to focus on one specific lens to those risks, and I'm going to be looking at the risk of unfairness or bias. Right? So let's talk about that. And the reason it's really important to talk about this is that AI today already is used to make consequential decisions for people and for society. I'll tell you in a moment about some maybe not too dramatic benefits, like how the portal camera works, and Apple recently also deployed this, and most video conferencing systems are now using automated AI cameras. Other important ones are access to opportunities. If you have any application or platform that recommends jobs to people, AI is making pretty consequential decisions there. I'll talk a little bit about AI in the criminal justice system. I'll talk a little bit about an example of AI to improve access to healthcare. And I'll also be talking a little bit about content moderation and preventing people from being exposed to harmful or abusive content. So bear with me for a moment while I unlock my, I have my iPad next to me with the slides as well, so I can see what slide is next, because I can't see the preview here. Before we get too much into things here, I want to take a moment, and although I left Facebook a week ago, most of my absolute beloved colleagues are still there, and they're doing amazing work. So if you want to know more about some of the work that we've done on AI fairness at Facebook the past couple of years, earlier this year in March, we put out a paper out on Archive where we share the approach. So you can look up, the first author here, Chloe Bacalar, for example, and you'll get to this paper. And I want to emphasize that a lot of what I'm going to be talking about today is not my own work. It's the work of this group of people and then some more. All right. So let's get to a concrete example. Okay. What you see here is the Facebook portal camera. And in fact, if I can, and if I don't destroy my desk by doing this, and I try to do this, I have one of them here right next to me, and I use this for video conferencing all the time. And it's pretty awesome. My parents live in Spain. My parents-in-law live in Germany, and our kids, their grandchildren, use this all the time. We send one of those to each of them, because otherwise our kids would be trying to talk to them, on the phone. The phone is never pointing in the right direction if you're using Zoom, Skype, or what have you, right? So what we did a few years ago now is build skeleton detection and pose detection algorithms that would work directly in the hardware that ships with the portal. So no data needs to go outside of the portal, which is cool. And the goal here was to build a bit of an AI camera woman or AI cameraman that would simulate what you would do if you had a person holding the camera and trying to keep everybody in the frame, right? We didn't want the portal to have mobile parts because that's slow and clunky and prone to error and breaking down. So what we do is we have a bit of a higher resolution camera with a wide angle. And then we just do digital zooming, panning, and all that stuff. And so the interesting thing is that as we were starting to work on this, and my team was very involved in this actually, one female engineer here in the US, who's a Black woman, realized that whenever she'd be testing the device, a very early prototype, together with a colleague, and she'd come into the room, she'd sit on the sofa, she'd be doing the talking, the camera would zoom in on him and would keep her out of the frame. So that's a pretty terrible experience to have. And of course, Joy Bolamwini, Timnit Gebru, many others have written seminal papers on how computer vision algorithms to detect people used to fail at detecting darker skin tones. In our case, they also failed at detecting people of a female gender presentation. And there's no question why that happens, right? Like the initial data sets we used to develop this were obviously biased, right? So this is an easy unfairness problem to solve, because what you do here is you say, well, you set a certain accuracy level, accuracy goal, and what you do is you make sure that you have representative test sets to make sure that your product is working for everybody. And then one of the most obvious fixes is to make sure that your training data is also sufficiently representative. Okay, so that's an easy example. Another actual example that we worked on, and that was, again, a few years ago, was we looked at a product that Facebook has where it recommends jobs near you to people. And so this is an old screenshot. The product doesn't look like that anymore. But here, the machine learning problem we have is one of ranking, because there's a pretty absurdly large number of job listings you could have access to, but only a few of them are going to be relevant to you, right? So the ranking algorithm simply tries to estimate what are the ones that you're most likely to interact with, apply to, etc. And the fairness question here is it going to work equally well for everybody? And in particular, the first grouping that you can think of when you ask that question is categories that are sensitive when it comes to access to job opportunities. We don't have race in this particular example or skin color, but we have age, people over and under 40 years old. And then we have gender presentation. Obviously, gender isn't necessarily a binary concept, but here we're binarizing gender presentation. So what you can do here is the obvious thing, which is create a test set that ensures that you're exploring all of these categories, and then make sure that the prediction accuracy of your ranking algorithm is good enough for each of these categories. And I'm going to pause here for a second. If you're in the audience right now, I can't see you, which really sucks. I would really love to be looking at all of you and your facial expressions. Hopefully, many of you are impatient and thinking, listen, this is really not enough. This is not only about the algorithm being accurate, enough for all groups. And I agree wholeheartedly, and we're going to be talking about that. That's only one small component of the whole fairness analysis. But if you go back in time and you think about me in early 2018, when I personally started to look at algorithmic fairness, what was on my mind was this. I was very naive. I remember attending the Fairness, Accountability, and Transparency Conference in New York in early 2018. And I remember being at a bar with people who had thought about this problem a lot more. And I would basically say something like that, right? I'd say, hey, listen, at Facebook, I've helped build a team that has put ML in the hands of every engineer. How hard can this be? We can build some code. I thought we can just do this, right? We can either use or build a library that tries to find biases in the data, whether it's test data, training data, etc. Maybe biases in the model, and then we can probably write some routines that just removes it, and we're done. And obviously, I was very naive, and some people in that bar threatened never to talk to me again. And I'd like to walk you through an example that opened my eyes as to why it's a lot more complicated. This is an example from 2016, and probably many of you are aware of this study that ProPublica made. The context here is that there's a company called Northpoint that built a tool used by judges in the criminal justice system to get a risk assessment that a defendant will go out to reoffend or to recidivate. And the idea is that the judge needs to make a decision whether to let the people go on bail or to make them await trial in jail. So it's a bail or jail decision. The AI doesn't make the decision, but it informs the judge. So what ProPublica did is they said, well, let's see whether there's a bias in those risks, in the way those risk scores are computed. And what they did is, one of the tests they did is they said, well, let's look at all of the people, whether black or white, who in reality are true. I'm gonna say true positives here. Positives in the sense that they will not reoffend, meaning they could go out on bail, right? And so for people who don't recidivate, what is their risk score? And it turns out they found out that the average risk score distribution was a lot higher if you're Black than if you're white for a population of people who would not reoffend. Conversely, they looked at the population of all of the Black and white people who would reoffend in reality, and they found that the scores were lower. The risk scores were lower for white people. And they concluded, they said, well, listen, your tool is biased. It's incorrectly incriminating Black people more than white people. And we could end the talk here and we could say, okay, fine, that's pretty terrible, and it should be fixed. But then Sam Corbett-Davies, who's a dear friend and a former colleague at Facebook, he's still at Facebook, and his co-workers looked at the same data and they cut it in a different way. And they said, well, why don't we group by risk score, right? And basically assess the calibration of the risk scores. So imagine that your risk scores are between 0 and 1, right? They said, well, let's pick, everyone who's got a risk score of like 0.3 plus minus some margin. And then let's group everybody who's got 0.3 by whether you're Black or white, right? And then look at what's the actual empirical rate at which people do reoffend. And they found that it was the same for Black people and white people. So they said, listen, if you take calibration as a measure of whether you have bias here, then you don't have bias. And this is interesting, and it kind of blew my mind a little bit. I thought, well, how can you be having something like fields like different false positive and false negative rates, which would mean you have a bias from that point of view, but actually you're well calibrated for everybody. So Isabel Kloman, who's another colleague still at Facebook, put together the following slides, and I apologize for the bad resolution here, but I'd like to basically walk you through how this is possible. Okay, so imagine that we had two groups of people. All right, we had circle people and we had square people, and imagine that in reality, the ground truth is that for circles we have 3 positive examples and 2 negative examples. So we have an average outcome rate of 60%. Now, if you're a square, for square people, we have 2 positives and 3 negatives. So the average outcome rate is 2/5. And imagine that you build a classifier, right? The classifier makes some mistakes. So that's the bottom of the slide. And what you get is that for circles, if you're a circle, you're going to get 1 false positive and 1 false negative. And actually, if you're a square, it's the same. You get 1 false positive and 1 false negative. All right. Now, you can see that overall, the predictor is well calibrated. And we're going to talk about that in a second, because the average prediction for circles is still 3/5, it's still 60%, and it's 40% if you're a square, right? So we can compute that. Now, when we say, well, are the predictions fair to circles versus squares, we could talk about the process for making predictions, and that actually is a most interesting discussion. But let's talk about the predictions themselves, right? So we're going to be looking at the metrics that I talked about earlier in reverse order. Let's first look at subgroup calibration. So as I said a moment ago, if you want to compute calibration, you look at your predicted positive rate, you divide it by the actual positive rate, and then you sort of take the ratio of that. If the ratio is 1, you're well calibrated. And in this case, we see that the predictor is well calibrated both for circles and for squares. Okay. So what happens now if we start to look at false positive and false negative rates? So let's go ahead and do that. Let's look first at the false positive rates, both for circles and for squares. So let's start with the circles. What we do is we look at all of the actual negatives, and we have 2 of them, and then we look at what fraction of the actual negatives were falsely predicted as a positive. And we can see that in this case, it's 1/2. So we have an average false positive rate of 0.5 for circles. You do the same math for negatives, and you find that your false positive rate is 1/3. Okay. If the positive prediction means that we're predicting that you will not recidivate and it's a positive outcome for the subject, then you can sort of see that making more false positive errors for circles favors that group compared to squares. And we can do the same thing for false negatives, and you can see that the picture here is mirrored. We're going to get a false negative rate of 1/3 for circles and a false negative rate of 1/2 for squares. So how is this possible? Well, the reason this is possible, and I apologize for the cluttered slide here. Maybe if you want, you can simply ignore the top half of the slide because we've already talked about that, and then focus on the two references at the bottom. Kleinberg, Mulanathan, and Ragavan in 2016, short after this study came out, wrote an absolutely beautiful paper that shows that in almost every single case, you will have trade-offs between different metrics of fairness, right? And in this case, what happens is that the empirical distribution of recidivism is different if you're a circle or if you're a square. If you go back to the ProPublica example, the problem is that in the data, the actual rate at which Black defendants will recidivate is higher than the rate at which white defendants will recidivate. And so if you're building a classifier that's well calibrated, where every individual score is well calibrated, then inevitably what's going to happen is that your false negative rates and false positive rates are going to be different for both groups. And it's a pretty tricky thing to answer, well, is that fair or not? You have to zoom out and you have to ask yourself things like, well, how did we collect the data? Are we policing every neighborhood equally? Are we making labeling errors, right? You even should sort of zoom out and look at questions like historical inequities, right? And what should we do about them? And ultimately, there's a picture that you might have seen. I like this picture quite a bit, although it has a bunch of imperfections. But it really illustrates that the question of fairness does not have one single answer, right? Here you have three people trying to watch a baseball game from behind a fence. And you could give one crate to each person, but because they're not equally tall, right? We have a little guy in the purple shirt here, he can't see, right? And the tall guy does not need a crate, right? So on the left, you're treating everybody equally, right? But the outcome is not the same. Not everybody can watch. On the picture on the right, you're focusing on the outcomes, on equalizing the outcomes. You're focusing on equity. Now everybody can see the game, but you're having to give more credits to one individual or not. What definition of fairness is appropriate entirely depends on the context and depends a lot on asking the right questions and on making sure that the right people are in the room for discussion. So, all right, you remember how I was telling you that I thought that you could write some code and you'd be done, you know, with solving fairness? One of the things that really came to me was that we needed a framework to ask fairness questions. So I worked together with an incredible group of people, experts in AI policy, moral philosophers, political scientists, and this is a gross, if you're an ethicist, please forgive me. This is a gross oversimplification of things, but it was the minimum set of questions that we could think about to really try to make sure that we're not taking a one-dimensional view of fairness, right? So we sort of thought, well, we need to start when we sit down with a product team that's putting AI, in front of billions of people. Let's start by asking the question of, are we in a case like the portal camera where it doesn't really matter whether the skeleton detection works a little bit better, for a type of person than another, as long as it works better than a certain threshold that guarantees that the product experience will be great, right? And then in that case, you ask yourself, well, what's the harm that comes from it working a bit better for someone than someone else? Maybe it's not that big, in this case. Then the next question that you need to ask yourself is one of equal treatment. And I'll give some concrete examples of that in content moderation in a second, right? So here the notion of fairness does become comparative rather than relative to a common threshold. And here the question can be, well, is the performance comparable across all groups? And one very important one, right, is that even if your treatment was the same for everybody, statistical differences in how people use products might still mean that the outcomes are different between groups. But you have to be able to justify those outcome differences and sort of feel comfortable with equal treatment. And then finally, and this is relevant to the ProPublica discussion, is you need to ask yourself the third level of questions, which is questions of equity. Are there historically disadvantaged groups that deserve special consideration? You can think about Black people, people of color in the US, for example, or you can think about different genders. And the question you ought to ask yourself if you're building a product is like, well, should I actually prioritize outcomes for a particular group? We've seen this at Facebook, for example, when Facebook focused on making sure that our marketplace for small merchants worked well for Black business owners who have been marginalized for centuries in this country and in other countries as well. Okay, if you want to remember one thing from this talk, it is that fairness is not a static thing; it's not a box you tick. Fairness is a process. And you need to surface hard questions like the ones we just talked about a second ago. In order to answer those questions, you need to have like a predictable and transparent process. And it has to be as participative as possible. Participative governance is something that I'm fascinated with, and I have more questions than answers. And then it's very important to also keep a record of, hey, these are the factors that we took into account when we made a decision, and here's why, right? And of course, if you're building an AI system or an ML system that you're deploying in production, you have to be asking those questions at every single stage. So what I'm going to do now in the next part of the talk is I'm going to talk about 3 different stages. I'm going to talk about potential bias when we collect data and when we label data. So that's like the labeling bias here, when you go from ground truth to labels. Then I'm going to be talking about algorithmic bias, so potential bias in the predictions of the algorithm. And then I'm going to talk about intervention bias, right? Because once you have predictions, think about those risk scores. If you're the judge, you're going to look at the risk score, and maybe in your mind, you're going to have a threshold, right, above which you're going to let that influence your decision in one way or another. Okay, so let's begin by focusing on labeling bias. And I want to make a reference to a paper 2 years old now by a bunch of colleagues at Facebook AI Research. What they did is they said, well, in computer vision, large rich data sets, going back to ImageNet and others, have really been revolutionary, right? They really have fueled the explosion of computer vision since 2012 or earlier, right? But if we start to break down those data sets into cultural and geographical, specific areas, are the predictions of the algorithms we train on those data sets equally good across regions? And the answer, of course, as you would imagine, is no, right? There's quite a bit of bias on where are the images collected from, right? So if you look at like the top 2 images, these are 2 different images of soap. It turns out that the accuracy is going to be different across different presentations, and the same for spices. And there's going to be a negative correlation with average income of the region from where those images come from. And the reason for this is that if you take any data set you want, and you break down the geography of the world by things like income, you're going to see that you tend to sample more images from areas of higher income relative to where people actually live, right? So the world, the image, where the images come from does not reflect the world population, and that's a problem. So here we haven't even started to label the images; it's just where the images come from. Another example. Oh, sorry, apologies. I forgot that I had this slide coming. Okay. Now imagine that you have a bunch of labels, and imagine, for example, that you're labeling content to see if it could be misinformation or not, right? And imagine that all of your labelers are people who live here in the Bay Area, right? So the Bay Area is predominantly liberal from a political ideology, and you're pretty sure you're going to see some type of biases, right? If you use labelers from here, right? So one thing that you can do is you can make sure that you group all of the content into that you group it by the actual risk that it will be misinformation, and then you split both your labelers but also your content into different groups, and then you do paired tests where you see whether the mapping from the ground truth, and ground truth merits its own talk. Often in industry, you obtain quote unquote ground truth by spending a lot of money on super qualified and redundant labelers who are super well trained, and you generate, like, people refer to like golden sets and stuff like that. And then you compare that to the much broader labels that are coming from the actual labeling process that you're using. And you want to make sure that if you're separating out the content that you're labeling, let's say by groups of publishers, if you're looking at misinformation, you want to make sure that you don't have a gap in the mapping from ground truth to labels, right? You want to make sure that gap is closed. Well, the example that I also think is really interesting is that the definition of the labels itself can also lead to bias. And this is an interesting study that looked at an algorithm used to prioritize who should get healthcare, right? And what the challenge here is that they found out that the algorithm would overpredict the need for healthcare for white people compared to people of color in the US. And digging into the reason for this, what they found was that the team who built the first version of this algorithm that predicts need for care used money as a predictor, right? They said, well, we can look at healthcare spend historically, and we can sort of say, well, if the healthcare spend was high, that's an indicator that there was a high need for care, right? And if the spend was low, then people don't need that much care. And of course, this would work if everybody had equal access to healthcare and equal access to money to pay for healthcare, right? But obviously, the key flaw here is that there is inequity in society, and that Black patients often don't get care because they can't afford it, right? And so a low cost doesn't mean that they don't need the care, right? So the solution for this is just to go deep into the proxy variable you're using and ask yourself whether it really represents the thing that you're trying to predict. Okay, so we've covered three aspects of the labeling bias part, or the data bias part, I should say. One is where the data comes from. The other one is, do I have biases in my labeling process? And three is like, is a label itself in its definition biased or not? So let's imagine for a second now that you have data that you're happy with, the distribution is fine, and that you have labels you can trust. Now you're going to go ahead and make predictions. And what I'm going to do is I'm going to use a concrete example from work that my team was involved in directly back in 2019, when the world saw the biggest elections in history, with almost 900 million eligible voters in India. Now, India is a very diverse country, diverse in religions, diverse in languages, diverse in cultures. And what we wanted to make sure is that if we were going to use AI to fight election interference during those elections, that we were covering the entire population well enough. And talking to the local team in India, we said, well, what are demographic dimensions that one would be worried about? And two of the ones that came up were caste and religion. But we don't collect information about caste or religion, and this would be pretty sensitive and complicated information to collect. So we're working with the local team. We said, well, what data that is less sensitive could we possibly use instead? And the suggestion was to use language and region. So that's what we did. We used language and region. And so before I tell you how we used it to make sure that the election interference protection was equally good for everybody, let me tell you a bit more about what the task is, how we're using a piece of ML for that. So what we do is, and most companies do, is that you have paid content reviewers, you have policies and content guidelines that explain what constitutes material that violates our guidelines to avoid election interference. So, for example, spreading certain type of misinformation about a politician would be such an example. But the problem is, of course, that it's a needle in a haystack problem, because the number of posts that actually discuss political or civic issues is very small. Like, most of the posts are talking about something completely irrelevant. So if you did random sampling of everything that is shared in India, you'd be wasting resources. And with a country so large, there's no number of reviewers you can hire to really have full coverage. So what the team that works on election interference did is to build a civic content classifier that predicts the likelihood that a piece of content is civic in nature and therefore high risk for election interference. So what I'd like to do now is I'd like to ask the question: does this civic content classifier work equally well across? We're gonna take languages in India as the example. Okay. So what we need to do here is we need to say, well, what does fairness mean here? So in this case, what we decided to do with the team is we said, okay, well, we're going to be prioritizing human reviews according to the probability that a piece of content is civic or not. So in this case, what we want is we want to make sure that those probabilities are well calibrated. And if I think that a particular piece of content in a language has a 60% chance of being civic, I want to make sure that the empirical rate is actually as close to 60% as possible. In this example here, and this is made up data for language 1, you can see that we would be actually dramatically over predicting, right? Because in this case, all of the content that we give a 60% score to only has a 20% chance of being civic. If for another language, we're making the opposite error, where we're under predicting, because in that case, for the same score, the actual rate would be 80%. And if this pattern was consistent, what would be happening here is that we would be spending way too many human review resources on language 1 and not enough on language 2, because content from language 2 that is actually high risk just would get lower scores, right? And wouldn't make it relative to content from language 1. So our definition of fairness in this case is calibration. It could have been something else, but we decided for it to be calibration. And so what we did working with the integrity team is we made sure that the civic content classifier was as well calibrated as possible across all languages, but also across all regions. And there's many ways to make sure that a probabilistic classifier is well calibrated, starting from making sure that you have properly representative data for all classes, but also making sure that the way you're training your classifier results in good calibration. All right, so we talked about the data, we talked about the potential bias in the predictions themselves. Now let's talk about potential intervention bias. So to do this, I'm going to talk about a fictitious data set here, but a very, very important problem, right? So one of the challenges that AI helps us solve is identify content that violates our policies, including misinformation, right? So imagine for a second that we had a source of content, an aggregated source of content coming from many publishers, where overall, empirically, we know that 30% of it is misinformation and 70% is not misinformation, right? And now what we're using a piece of AI to do here is we're flagging content we believe is misinformation so that human reviewers can take a look at it and make a final decision on whether to take it down or not. Your perfect classifier here, we have a confusion matrix that looks beautiful and that has 0 false positives and 0 false negatives. But in reality, of course, that's never going to be the case. You're going to have some false negatives and you're going to have some false positives. Again, these numbers are made up, right? And one of the decisions that we can make in our classifier is depending on what we think the cost of a false positive is relative to the cost of a false negative, is we just adjust the decision threshold, wherever we want. I'm going to skip over the 2 trivial cases where you would set it at the extremes because those would be sort of like useless classifiers, and then you sort of put it, whatever seems reasonable to minimize the overall cost. Again, given your cost of a false positive and your cost of a false negative. So far, no fairness issue. But let's talk a little bit about a fairness issue. What if your content is coming not from one, but from multiple publishers? Think about what sources you get your news from, right? Storing many publishers, even if you think about sources you don't get your news from, but you know they exist, right? Now, the fraction of that content per publisher that is actually misinformation is likely to change over time, right? It's not going to stay the same. And you're going to have some publishers that overall generate more misinformation than others. So the question here is, where do I set the decision threshold for each of those publishers, right? One way you could do things is you could say, well, I'm going to set my decision threshold at the same point. And let's assume for a moment that all of your classifiers are also well calibrated, just to make things easier, all right? If they're not well calibrated, you can then compensate for that using the decision threshold. But here, I really want to focus on the meaning of the decision threshold itself when the classifiers are well calibrated. So I'll say it again, imagine that we have probabilistic predictors that are well calibrated for all of my publishers, okay? If I set the decision threshold to the same value for everybody, because some publishers have a higher percent of misinformation in reality, what's going to happen is if I look at my confusion matrices, I'm going to have the same problem as I had with the ProPublica criminal justice system example. I'm going to see more false positives and more false negatives, or bigger false negative and positive rates for some publishers than others. If I tell you that the relative volume of stuff that will be taken down is bigger for some publishers than others, you will not be surprised, because I'm using the same threshold for everybody. Now, what you could do is you could say, well, I'm not sure if calibration is the right notion of fairness here. Why don't we try to equalize false positive rates across publishers, right? You could do that, but if you did that, that would mean that you would then have to pick a different value, a different decision threshold for different publishers. So what that means is that if you take the same piece of content, right, but it comes from a different publisher who produces more misinformation, then you have to actually treat that piece of content differently if it came from that publisher than if it came from another publisher. So if your notion of fairness here is that you're going to treat all content the same, irrespective of where it comes from, then you have to be ready to set the decision threshold to the same value for everybody, and then accept the fact that the volume of stuff you will act on will be bigger if a publisher has a greater content, a fraction of misinformation, but also you have to accept that the false positive rate will also be bigger for that same reason. Okay, So I'm getting towards the end of the talk, and I'm very happy to see that I'm actually not behind schedule, or at least not yet. So I'm just going to take a look at what is next in store here. Let's see. All right. So I have one more topic to touch on, but we're gonna wrap this part. So what I told you about is that fairness is a process, and that what you need to do is you need to have a playbook for asking hard questions about fairness, with the understanding that there is not one definition of fairness, and that many definitions of fairness contradict each other. You need to have transparent processes for resolving these questions, and you need to record the decisions. And then you need to do this at every stage of your ML pipeline. I see Fernando on the screen, but just a second, Fernando. I have one more thing that I'd like to talk about. So after working on fairness in AI, I spent the last year looking at the people behind AI. And I was inspired by a conversation I had with Yo-Yo Ma, the world-class cello player, who attended the NeurIPS conference in 2018. And I remember I was privileged to be able to chat to him backstage afterwards. That's me, the ugly-looking guy with the red hat is me, and then Yo-Yo Ma is there. And I remember I was very preoccupied with the question of trust in AI. And I asked Yo-Yo, I said, well, how would you decide if you trust a piece of AI? And he said, you know, more than the specific properties of a piece of AI, what I care about is the people who build the AI. Who are these humans who build that AI? What are their backgrounds, and what are their motivations? And more importantly, what are their intentions, right? And this is me paraphrasing our chat. So the past year, I did dive quite deep on diversity and inclusion in AI and in AI organizations. And one of the observations that I think everyone can easily make is that if you look at any AI team, whether in academia or in industry, these teams are remarkably non-diverse and remarkably non-representative of the diversity of population in the world. And initially, I think one of the big misconceptions that exist on diversity and inclusion is that it's mostly about recruiting. It's mostly about going out there and hiring more people that have a female presentation, or diverse genders, or maybe people of different ethnicities or skin tones. And that's not the case. There's a number of studies that have come out recently that look at the retention problem. The real diversity and inclusion starts after people have joined the team and once they're in the team, right? And you see that attrition tends to be much higher for underrepresented people. So one of the things that we learned is that diversity and inclusion is mostly about making sure that we build teams that are diverse and inclusive with the people who are on the ground. The second thing is there's quite a lot of effort on education and awareness, and there's this idea that if we make people aware of the problem, people will change their behaviors. And I found that not to always be the case. I think people end up doing what they're paid for, and so that's where you need to act. And then the third one, sort of remark before I share a story of something we did, is I'll just tell you. Actually, I'll illustrate this with a story. I remember working on the project that I'm going to tell you about, and being in a room where it was 12 of us, and there was 11 women and me. And this is people, within a pretty large AI org that is not 50-50, across binary genders, right? And so one of the observations is that underrepresented people, people from underrepresented groups tend to do most of the diversity and inclusion work. And because they do that, but then the challenge is that work tends not to be rewarded. And they could have been doing work that gets rewarded instead, but they didn't. And then third is that people from the represented groups end up carrying a big burden sometimes of negative perception for being the ones carrying that load, and almost being perceived as activists in ways that are negative. So I call it the triple whammy in a way. So a project we worked on that I was super involved in was to try to take a slightly different approach. So to try to explicitly address the reward problem, what we said is well, we need to build expectations for contributions to diversity and inclusion directly in how we evaluate people and how we decide how much to pay them and whether to promote them, right? And that cuts both ways, right? It means making sure that if anyone really does meaningful work, that they systematically get rewarded and they don't get left behind. But it also means holding people accountable. It means that if you have guidelines and you're expecting certain behaviors from managers and leaders, it means that if they don't do it, then they will get a worse performance review and less money and a smaller chance of being promoted. The other thing we did is we thought carefully about what these expectations should look like, and we ended up having out of 4 sets of expectations, 3 of them were related to inclusion, things like making sure that you have career growth plans that are super well thought through in writing, and that you have them for every single person in your team, that you don't forget anyone. A lot of work on making sure that people have access to resources and support groups. And then one obviously related to recruiting, because you still have to be willing to slow down your recruiting to make sure that you're giving an equal opportunity to as many people as possible. And then, yeah, I mean, I think I'm repeating myself. The third one is make sure that you connect that to what people get paid for. All right, so I'm gonna try and wrap it up. We talked about a lot of things. I like to say that AI fairness is not primarily an AI problem. If you talk to philosophers, political scientists, ethicists, they get pretty frustrated that people like me, who are computer geeks and math geeks, are now rediscovering moral philosophy, when humanity has been obviously talking about that since the ancient Greeks and before. Connected to this, Sandra Wachter, who's an amazing legal scholar who's written a lot about AI fairness and AI transparency, says that we AI practitioners need to own things, and we need to educate ourselves in social sciences and humanities and not burden, not put all of the weight on AI. We need to build cross-disciplinary teams in AI, and I'm super happy that before I left Facebook, we built a pretty cross-functional team. And then finally, I talked a little bit about diversity and inclusion, which I think is the next frontier when you're thinking about the ethics of AI. And I think that with this, I'm happy to stop here. And maybe, Fernando, I don't know what's best. Should I stop sharing my screen so that we can see both of us bigger?
I think so. And if you need to come back, yes, come back to it. I think it's better if people that want to ask a question just raise their hand. Somebody sent me a question by email, so I will read that one first, and then people can start raising their hand, and I will be calling them to ask their question live. Okay, so the question that we got through email is, do you perhaps have any insight or ideas on how we can possibly use existing models to incorporate equity between quotes to achieve fairness between quotes without changing data gathering? For example, embedding inductive biases that would reflect our ideals on the notion of fairness.
Sorry, I'm sorry, Fernando. Could you repeat? I know it's a long question, but
yes, that's the thing. So it's usually, this is why it's better for people to raise their hand, and I'm going to try to read again. Okay, so do you perhaps have any insights or ideas on how we can possibly use system models to incorporate equity to achieve fairness without changing the data gathering? For example, embedding inductive biases that would reflect on our ideals on the notion of fairness.
Yeah, I think these questions are a little bit modular. In my opinion, the data gathering should be always as representative as possible. I would be very nervous about biasing the labels themselves. I think, or even biasing the data collection. I think one should aim for matching the distribution of the population you're going to be making predictions for. In terms of reflecting one's values, or if you're aiming for equity into the modeling process itself, you know, the most obvious thing that comes to mind is to put a different weight for false positive or false negative errors for members from different groups. Again, I think that's something that you can do in a quite modular way. I'm a huge fan of building as modular systems as possible, where you know that you have a boundary where, like, hey, your predictions are well calibrated, you know, relative to a data set that is as accurate as possible. And now, you know, you're going to make decisions. You can certainly build cost functions that reflect your ideals. I think that's you know, how I would approach things.
Okay, thank you. So does anybody wants to raise a hand and ask a question? Okay, so while shy people jump into the conversation, let me ask you a question about from my own. Is, I mean, you use Sandra Watcher in your last slide, and I really like all the work that she's been doing in contrafactuals for explainability, which is in a way very well connected to AI. And I like that quote of saying, look, fairness is a human problem, and this is why we might not be good at solving it. Do you think her ideas of contrafactuals for explainability can be used in fairness too?
Yeah, absolutely. Absolutely. I think that two areas of research that I'm excited about that connect to fairness. One is actual causal models. A lot of the biases we see are the result of models that will attribute an effect to the wrong dimension. Like, for example, you think about the criminal justice system model, right? Like, probably if you used skin tone as an input, it would probably use that and happily say, oh yeah, if you're black, you're more likely to be you know, to reoffend. If you had a causal model that really understood, you know, the circumstances, then I think you would sort of avoid things like that, and you'd be able to actually use more information correctly. I think counterfactuals, similarly, if you want, you owe it to people to tell them what should they have done differently in order for a prediction to have been different, right? And I think that it's only fair once you think about it. I agree that the short answer is yes, and I think I'm a huge fan of Sandra's work as well. I'm going to open the WOVA app myself in case there's any. Oh, I saw the first one.
Yeah, there is another one.
Yeah, go ahead.
No, I mean, there is another one in WOVA that said, when you mention people getting paid, you mean in monetary terms, or you're also implicating getting paid in terms of fulfilling values, have a common vision and a mission? Yeah,
thank you for the question. I was thinking in the most simple, practical, down-to-earth world. Anyone who has worked in industry knows that you have performance reviews, sometimes every 6 months, sometimes every year. You have levels, you have ratings, you have promotion decisions, and all of those result in a number in your bank account every month or every 2 weeks. That's what I was talking about. Because at the end of the day, in this case, what I was interested in is solving two things. One, making sure that people get recognized if they're doing very meaningful work that contributes to diversity and inclusion. And of course, you can and you will get recognized by your peers, right? And you will get also the satisfaction of doing what you know is right. But the truth is, since we're talking about fairness, it's pretty unfair if you've been spending a whole bunch of your time doing that impactful work, and then other people who ignore it completely and just focus on like short-term business goals only, you know, get all of the reward, right? So I was really focused on like the super practical, down-to-earth, you know, actual dollars or euros or whatever.
Thank you. Do we have any other question? Anybody that wants to raise their hand and jump into our conversation?
What I don't know, Fernando, is if people can actually raise their hand.
Yeah, they can raise their hand. So
in Zoom, okay.
Yes, there is I mean, it's on the bottom bottom of your screen.
Oh yeah.
You should be able to hit the raise hand and then Jose will let you in.
Okay. I also recognize that it's almost 8 p.m. in most of Europe, and you've been going at this for a long time.
Yes. So if there are no more questions, I just want to thank Joaquin again for coming here, for sharing the work that he has done and other people has done in fairness. I think I really like that you is not only focus on yourself, but focus on a very important topic. And I hope we can see each other soon, and I can get a paella from you too.
That would be wonderful. Okay, thank you everybody. Right. Have a great rest of the conference. Thank you so much, Fernando and Jose, and have a great evening, everybody.
Okay, thank you, everyone.